Hi there. We talked today in class about chain rule, and the notational form of chain rule is located on my notes, which are on my website, as well as in the front of this section of your textbook. Chain rule in a nutshell says that if I have a function within a function, or a function within a function within a function, right? It doesn't matter how many there are, but if I have a function nestled within another function, then I take the derivative of the outside function, whatever it happens to be, and I initially leave the middle function alone. And after I've taken the derivative of that outside function, again leaving the middle function alone, I then multiply to it the derivative of the middle function. I like to compare this to those little dolls that you see where, the big doll holds, so when you pull off the top half of that big doll, there's a little doll sitting inside of it. When you pull off the top half of that little doll, there's an even smaller doll inside of it, right? That's kind of how chain rule operates here. And so I've selected 4 homework problems, or ones I should say like your homework problems, to demonstrate what chain rule is talking about. So the first is number 8, which says y equals the quantity of 2x cubed plus 1 squared, and we're asked to take the derivative. Our cue that chain rule is probably going to come in are parentheses, and so when I look here I notice these parentheses, and so I'm going to be thinking I'll probably be using chain rule. Okay? And when chain rule comes in, I'm going to look first for what is that outside doll, the big doll holding the little ones inside. Right? And in this case, the outside doll is this squared, right? In fact, you can even see the arms of the big doll, right? So the square is holding this 2x cubed plus 1. And so the first part of my derivative is going to be to take care of this squared. And we've been doing that using power rule, right? I can bring down that exponent, and I can subtract 1 from the exponent. And then the important thing with chain rule is that when you deal with that outside function, that large doll, make sure you don't touch what's inside. Okay? It's only after doing that power rule, it's only after taking off the top half of the doll that we are then allowed to see what's inside. And inside the doll, when I take that derivative of the guts here, which is 2x cubed plus 1, the derivative of 2x cubed is 6x squared, and the derivative of 1 is 0. So it's just 6x squared. And again, we multiply these two pieces. So again, outside doll, the squared is on the outside of the parentheses, so that's what I take care of first. I do power rule, bring it down, subtract 1 from the exponent, but leave the guts alone. Then times the derivative of the guts. After that, you just kind of clean it up. 2 times 6 is 12, x squared, 2x cubed plus 1, and I don't really need that 1 as an exponent. And that's my answer. So the second one I picked is number 15, which is y equals the cubed root of 9x squared plus 4. Just like we've been doing, our first step when we see that radical is going to be to rewrite our function without the radical in terms of fractional exponents. That way we can see, is chain rule in place, or is it just power rule? And in this case, when I rewrite that, I see those parentheses. That's my signal that chain rule is coming in, and so I'm going to be looking again for that outside doll, that function holding another function. And in this case, the 1/3 is my function holding another function. So derivative of y is dy dx, and I'm going to take care of this 1/3 first. It's power rule, so you bring down the 1/3, and then subtract 1 from the exponent. 1/3 minus 1 is negative 2/3. And again, make sure you leave those guts alone initially. After you've completed the outside function, then you multiply by the derivative of the inside function. Derivative of 9x squared is 18x. Derivative of 4 is 0. Okay, so cleaning this up a little bit, the 3 and the 18 will simplify to make 6x, and this will be over 9x squared plus 4 to the 2/3. Okay, so number 8 up here and number 15 down here are what I would term kind of your basic chain rule. There's not a lot to them that you have to be careful about beyond the implementation of chain rule. Obviously, you need to be careful you don't touch the guts. You need to be careful you don't accidentally lose a negative or lose an exponent or something like that, right? So the implementation of chain rule has some tricky parts, but on the whole, those two problems are what I would call kind of our basic chain rule. Okay, there are times, though, where chain rule comes into play within the context of other rules, like product or quotient. And that's where you need to make sure you're being very, very careful. Okay. So we have here two functions being multiplied together, which means product rule. This is going to be my 1 and my 2. Derivative of f is f prime. I have 1 d2. Now when I'm taking the derivative of that second function, that quantity 3x minus 9 cubed, I notice the parentheses. And again, parentheses is your cue that you should be considering chain rule. Okay, so with those parentheses, I'm going to be looking for my outside function, which is that cubed. I'm going to bring that 3 down and subtract 1 from the exponent, and again, leave the guts alone. Then you're going to times by the derivative of the guts. The derivative of 3x is 3, derivative of 9 is 0. Okay, so that's my 1 d2. Then I've got plus my 2, which is 3x minus 9 quantity cubed, d1, derivative of x is 1. Okay. Now eventually I will be looking for terms that I could factor out, but before I get to that, I'm just going to clean this up a little bit. I don't like all the extra dots. I'm going to go ahead and combine some pieces here. And so 3 times 3 is 9. The x will sit next to it. And then you have the quantity 3x minus 9 squared. Okay. And so at this point, we're going to be looking for, is there anything that the two terms of my current equation have in common? Right, so here's one term, here's the second term. And when I look at these two terms, I notice they both have a 3x minus 9 quantity squared, which means I can factor out that 3x minus 9 quantity squared. And so what will I be left with? Well, in this first term, the 3x minus 9 squared went away, so I'm left with 9x. In the second term, 2 of the 3x minus 9s went out, right? But there were 3 originally, which means I'm left with that third 3x minus 9. So then cleaning this up a little bit, 3x minus 9 quantity squared, 9x plus 3x is 12x minus 9. I'm looking here, I realize, you know, I could factor out a 3 here as well. So I'll go ahead and do that, which would leave me with 4x minus 3. So there's product rule. Okay, with quotient rule, I went ahead and picked number 32, which says h of t equals the quantity of t squared over t cubed plus 2, all squared. And you have a choice here that you need to make. You'll get the right answer either way. You can leave it as it is, and you'll apply chain rule. And within the context of applying chain rule, you will also apply quotient. Or, if you wanted, you could split this and make this t squared squared, just do the fourth, over t cubed plus 2 quantity squared. And what that'll do is, rather than chain rule being the first rule applied and then quotient rule being applied inside, you're now going to have quotient rule applied first and chain rule applied inside. Okay, so again, you'll get the right answer either way. You really just need to choose which one you prefer. I'm going to go ahead and go with this first one of leaving it the way it is. Right? And so I'm looking here, I see massive parentheses, so I'm thinking chain rule. Okay, and so I'm going to be looking for that outside function, which in this case is that 2. So derivative of h of t is h prime of t. I'm going to bring down that 2. And I'm going to subtract 1 from the exponent, but leave the guts alone. After I've done that, I'm then going to multiply by the derivative of the guts, and here's where my quotient rule comes in. I have low d high minus high d low all over low squared. At that point, we're going to be looking for, is there any sort of simplification I can do? And initially here, I'm just going to set this first term kind of side by side here, 2t squared over t cubed plus 2. And I can do that, right, because the 1 doesn't matter. If it was squared, I'd need to split the squared between the numerator and denominator, right? But it's 1, so. But I'm going to leave that first term like it is, and I'm just going to focus on this second term. I'm going to go ahead and distribute that 2t in, which will give me 2t to the 4th plus 4t. And I'm going to distribute this negative t squared. Actually, it's not really a distribution. I'm just going to multiply the two terms to make negative 3t to the 4th all over t cubed plus 2 squared. Okay. So I still have that 2t to the 4th over t cubed plus 2. And I see 2t to the 4th minus 3t to the 4th means 4t minus t to the 4th, because 2 minus 3 is negative 1. And again, I'm just going to keep simplifying this second term as far as I can before I combine it to that first term, because this first term looks pretty right now, right? Everything's factored that can possibly be factored. It's sitting nice. I want to make sure I get this second term to be factored as much as possible so that when I combine them, I already have a factored final answer and I don't have to do any additional factoring. So I just let this first term just kind of fall down the page and I focus on this second term. Okay. And so looking here, it looks like I'm almost done. I do though notice that I have some t's here that can get pulled out. So again, this first term is just going to get rewritten. I have a t, 4 minus t cubed. And now that that's done, I'm pretty happy with this. This looks factored, and so I'm going to go ahead and combine my two terms now. I have 2t to the 5th, because t to the 4th times t is t to the 5th, 4 minus t cubed, all over t cubed plus 2 quantity cubed. Because I have 2 here, and 1 here, which will make the 3. Okay. So quotient rule is a lot, right? My best recommendation, make sure you're just going very slowly, very purposefully. Think through every step. Watch for those parentheses, right? That signals chain rule. Okay. And account for every negative, every exponent, every variable. Right? Just be very careful, very purposeful. Okay, so the final thing I wanted to talk about, it's not a homework problem, although you will see ones like them on your homework, but they're your trig functions. When they come in with chain rule, there are two you need to be aware of that are chain rule, even though they might not have our parenthesis signal. Okay, the first one would be one that looks like this. Y equals sine x, and that means to the 6th, right? We don't see our parentheses here, so there's not anything that in the initial write-up that might signal chain rule, but the parentheses are there, right? We are allowed to write this way, but technically this function is sine of x to the 6th, right? And so there are your parentheses. And so my recommendation is if you see anything inside that trig function, rewrite it so you can see your parentheses, right? And so we're going to take the derivative here. Derivative of y is dy dx. We now have our parentheses so we can see our outside doll, our outside function. I'm going to pull that 6 down. Subtract 1 from the exponent, but leave the guts alone. and then times by the derivative of the guts. So 6 cosine x sine x to the 5th. Okay. The other one, which is again a trig relationship here, is when you have this cosine of 2x. Again, your parentheses may not be written, but they're there, right? Our parentheses are located technically around that 2x, right? But because the 2 and the x are being multiplied, we don't have to write those parentheses. That 2x is already contained within cosine x. The only time we have to write the parentheses is if you have two terms added together or subtracted together within a trig, right? So we don't have to write the parentheses, but they are there. And so again, if you see anything inside that trig, you see an exponent inside that trig, you see something attached to the x in some way, shape, or form. This could be x squared or x to the 5th or root x. If there is anything inside that trig, you rewrite it with parentheses so that you can see your functions, which one's the outside and which one's the one that's being held. Right? So then we have dy dx equals, and in this case, my outside function, the one doing the holding, is actually the cosine. Right? It's holding those parentheses. It's holding that 2x as a function. And so derivative of cosine is negative sine. And then it's not going to be negative sine x, it's going to be negative sine 2x, because again, we need to leave those guts alone. And then after you've done that derivative, you then multiply by the derivative of the guts, which in this case is 2. And so my answer is negative 2 sine of 2x. So there are some examples of chain rule.